Video, we're going to take a look at how to identify how many significant digits, also known as significant figures, a measurement number contains. All right. So the difficulty of doing this is identifying whether or not zeros in a number are significant. All non-zero digits are always going to be significant. Okay, so non-zero digits, we got a 2 and a 1 in this one. Non-zero, we have an 86 in that one. So are the zeros that are left over going to be significant? And so the first question that you're going to ask yourself, is there a decimal in the number? And if the answer is yes, we're going to perform an action. And if the answer is no, we're going to perform a different action. Okay, so if the answer is yes, then we're going to say arrow from the left. And if the answer is no, then we're going to say arrow from the right. So what do I mean by that? So we're going to shoot these magic arrows, and these magic arrows can pass through zeros, but they get stuck by non-zero numbers. All right, so we're going to take a look at the left number up here. Is there a decimal? Yes, there's obviously a decimal, so we shoot an arrow from the left. Okay, that arrow is going to go through the zeros, through the zeros, through the zeros, and stick in the 2. All right, what's left? The 0 on the other side. So the digits that are left over after that arrow sticks are going to be the number of significant digits in that measurement. So in this case, we have 3 significant digits. The arrow does not pass through the 2 and the 1 and then eliminate that 0 on the right-hand side. Okay? If the answer is no, there is no decimal in my number, I'm shooting an arrow, same magic arrow, but this time from the right. And again, that magic arrow can pass through zeros, but it sticks in a non-zero digit. So we have whatever's left over, 2 significant digits for that number. All right, so 3 for this one, 3 SD, shorthand, and 2 SD for that one. Okay, so that's simply what it is, right? So is there a decimal? If the answer is yes, you're going to shoot the arrow from the left. And if the answer is no, you're going to shoot the arrow from the right. Let's take a look at some examples. Let's say we've got 0.208600. We ask the question, is there a decimal? The answer is yes. We shoot the arrow from the right. That arrow goes through the zeros, up, sticks in the 2. How many digits left over? Those are the significant ones. So in this case, that's 6 significant digits. All right, let's take a look at another example. How about 863.0000? So we ask the question, is there a decimal? The answer is yes, there is a decimal. We shoot again from the left-hand side. That arrow sticks in the 8, doesn't make it through anything. That means all of the digits in that number are significant. Okay, so that looks like 7 significant digits in that number. Let's take a look at another one. Let's say it's 3002. We say, oh, wait, there's no decimal in there, yeah? We shoot an arrow from the right. That arrow, again, doesn't make it past the 2. That means everything in there is significant. We have 4 significant digits. How about an extremely large number? Ask ourselves the question, is there a decimal? The answer is no. We shoot from the right. And that arrow goes through all of those zeros before sticking in the 42. That means you only have 2 significant digits. All right. Now, why is this important? Because when we actually want to do some math with significant digits, we have a rule in what place to round our answers to. And it all depends on the significant digits. All right. So let's take a look at what this rule looks like. Okay, so here we're making a density calculation, and density is mass divided by volume, and I've got my 2 measurements. My mass is 262.40 grams. My volume is 30.1 milliliters. So first step, identify the number of significant digits. The answer is yes, there is a decimal. So we shoot from the left. Bam, that sticks in the 2, which means all 5 of those on the top are significant. Same thing on the bottom. Answer to the question is yes, there is a decimal. We shoot from the left. Again, it sticks in the 3, which means we have 3 significant digits on the bottom. Okay, so the rule here is when we do this division, we need to round our answer so that it has the same number of significant digits as the measurement that has the least number of significant digits. So that means we're going to round our answer to 3 significant digits. So when I throw this ugly thing in the calculator, we end up with an unrounded answer of 8.717607973. And we're going to round that to 3 significant digits. So we start over from the left and we count 1, 2, 3 spaces. So that means that we are going to round to that space right there so that we end up with 3 significant digits and only 3 significant digits. All right, so obviously when we round, we look at the digit that comes after the one that we're rounding to. It's bigger than 5, which means our digit goes up. So we're going to round this guy to 8.72, and the unit here is grams per milliliter. All right, so 8.72 has 3 significant digits. We can check. Yes, there is a decimal. We shoot the arrow from the left. It sticks in the 8. There are 3 significant digits in that answer. All right, so you need to first identify the number of significant digits in the measurements that you're using, and then you need to round your answer to the one that has the least. Same number as the one that has the least. Here's another example. This one's from physics. We're using the equation force is equal to mass times acceleration. So let's say we measure the mass to be 0.0240 kilograms, and our acceleration is 10 meters per second squared. So first we identify the number of significant digits. This one has a decimal in it, so we shoot the arrow from the left. It pierces the first 2 zeros and sticks in the 2. So we're looking at 3 significant digits in that number. The 10 does not have a decimal. We shoot the arrow from the right, passes through the 0, sticks in the 1, which means we only have 1 significant digit over there. The rule for multiplication works the same as the rule for division. We round our answer to the same number of significant digits as the measurement with the least. So we need to round our answer to 1 significant digit. So without rounding, we get an answer of 0.240. And we need to make sure we only round that to 1 significant digit. So moving in from the left, that's our first significant digit, which means we look at the digit that comes after for the rounding part. It is less than 5. The 2 stays the same. So our answer then is 0.2, and this is the weird unit, kilograms meters over second squared. Don't worry about that. Just double check your answer. Does that only have 1 significant digit? It's got a decimal. We shoot from the left, passes through the 0, sticks in the 2. Yeah, we only have 1 significant digit in our answer. All right. There is a separate rule for addition and subtraction. You can look that up. In other cases, we do not often add and subtract measurements in my chemistry and physics classes. So I'm just going to stick with the multiplication and division part. That's it for now. See you next time.